Welcome to Slight Reliability, the show where we learn SRE and observability 1 week at a time. I'm Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn about SRE and observability 1 week/2 weeks at a time. Today, I'm here with Martin Thwaites, who is a principal developer advocate at Honeycomb. Hi, Martin. How are you?
Hi, Stephen. Thanks for having me. I'm doing amazing. Just come back from a bit of traveling and in between, thought we'd do something like this.
Where did you travel to?
Last week I was in Missouri, in Kansas City, which is not in Kansas, doing a conference called KCDC, talking about OpenTelemetry and a bit of this ODD stuff that we're going to be talking about today, hopefully.
And so this ODD stuff, the topic for discussion today is sort of around observability for developers. Is that what ODD is about?
So that is a really interesting, nuanced little argument. And if your readers want to go and have a look on the Honeycomb blog, my colleague Jess literally wrote a blog post, which was kind of half rant, half blog post about ODD and the fact that the D in ODD, which does stand for driven, really, doesn't actually mean drive because nobody wants any more ODDs. It's a really interesting blog/rant about this thing. But yeah, it's observability driven development or observability during development is kind of the idea of how do we bring what we know as observability that we do in production and how do we give that to developers to bring feedback loops closer. My whole stick with this is, if you think about where Agile came from in development terms, it comes from extreme programming, which was all about feedback loops to what we're doing. And observability is kind of like the closer feedback loop than customers for your production systems. And how do we then get those feedback loops even closer? And how do we get the feedbacks of whether our observability is doing the right things closer to development? And sometimes when you're running a development workflow with 17 microservices and you try and run that up locally and run all 17 microservices and you attach your debugger to the one in the middle, it's quite hard. And it's never works. So how do we take what people do in production to debug these systems and do that locally? And it just makes the whole process so much smoother.
I'm really looking forward to diving into this topic, but just before I do, I wanted to give you a chance to sort of introduce yourself. And obviously, you're a principal developer advocate at Honeycomb. But what is your background? How did you get into this space?
So I've been a developer engineer for years, which is a number greater than 1 and less than 100. I've been doing this a while, and all of that time, I have been pushing for, I've always been the sort of person who runs systems as well as builds them. I've not worked for the massive big corp that has 17 layers of operations teams between me and production. I've always been either one level removed or the level of somebody who would build and deploy systems. So I've been working in the sort of logging, like way back, sort of doing logging, centralized logging. I was one of those early adopters of how do I don't want to FTP my logs off the server and grep them. Like, no. So I was always looking for how do I do things better? And I spent, let's just say 20 years doing that kind of thing. Being an engineer, I have a background in analytics, so doing systems analysis and that kind of stuff before I became a programmer. And I came through testing as well. I spent 4 years as a tester, I think, doing automation testing and all that kind of stuff before I became a programmer. And then I started programming and then building and running teams that do all of this kind of stuff. And about 4 or 5 years ago, I decided to go independent and take what I'd done for all of these big companies or medium-sized companies and try and do it for more companies at the same time and spread that knowledge. And then, I was kind of been working for Honeycomb for about 5 years as an unpaid library maintainer because I wrote the .NET library for them when I'm pretty sure that Christine and Charity didn't know what .NET was. I mean, they knew what .NET was, but they had an API and I wanted to use it. So I wrote an SDK for them. And I've been one of the founders of the Pollinators community that we've got of all the Honeycomb customers and customer adjacent people that chat about stuff. And then about a year ago, they said, we would like somebody to come and help us in the EU and in Europe. Maybe we should hire Martin because he's been talking about this stuff and talking about Honeycomb and not getting paid for it. So maybe we should bring him on board. And that was that. Been working in the developer advocacy team and for about 18 months now.
You kind of covered a little bit in your intro, but why would a developer want to make their code observable? What's the benefit to a developer?
If we talk about why a developer should put observability in for production as the starting point. Now, in that scenario, as I've said to a few people recently, actually, if you get a bug from your support team, they come in and say, George from X company is having a problem. Now, I've been doing this for long enough where that was the extent of the bug ticket. George from such and such a company is having a problem. Now, that's not good enough, really, but it's not, maybe we look at some metrics on a board and say, oh, yeah, there's such and such a company and there's George on that little spike. I can see exactly where that problem is. Now, the times in which that happens can be counted on no hands whatsoever. What you actually end up doing is you end up hunting through code and going, well, maybe he's having a problem on the product page. Let's have a look at the product page. I mean, and then you have levels that, they might say he's having a problem checking out. The problem might be he's running a bit slow when he's checking out. And you'll get these little tidbits of information. And that makes our job as developers really hard to find where the problem is. Making things observable is about understanding the inner system state from the outside. And what that really means is if we are looking at the inner system state after the fact of a problem happening, and we've got all of that inner system state in memory somewhere, like that might be in a observability platform, it might be a stack dump, if we can get all of that inner system state when that problem occurred, we are in an amazing position as developers to go, that little needle in the haystack is right there. And we can go and fix it. And then we can pass it back and say we've fixed it. And that's really where observability comes in, which is why we always say that observability isn't about logs, it's not about metrics, it's not about traces, it's not about profiles, it's not about exceptions, it's not about events. I think I covered them all. Because it's temple, not 3 pillars. So it's not about that. It's really about our ability to understand when things happen, why they happen. And that, from a developer's perspective, if somebody comes to you and say, here's a full stack dump of all of the memory of exactly when this happened, then you've got the tools to be able to analyze that, then that's the best thing that you can have. Run it up in Visual Studio. It'll show you all the lines of code that are being hit, all of the objects that were in memory at that particular time. And that's really where it comes to, if I make my code observable, I'm making it so that I can get that information out when things go wrong.
I see 2 real massive benefits there. So you're a developer, it really helps you debug and sort of identify issues quickly. I guess that reduces toil, this is one part of it, but it also, I guess, reduces cognitive load because you don't have to think as hard because the information's just there. You don't need to go on a hunting mission and go, where could it possibly be?
Yeah, I mean, I can't think hard anymore, so stopping the thinking hard would be a thing. I mean, the 2021 Accelerate DORA report had a really interesting little paragraph in it that says, paraphrasing, but teams with observability write 4.1 times. Well, let's get this right. The teams with observability essentially write more code, and high-performing teams are 4.1 times more likely to have observability. And these are the teams that write more code. And the reason why they write more code is they spend less time developing, fixing bugs, investigating bugs. Because, well, the bug happens, you fix the bug, and then you go back to what you're doing. If you have to page out less memory from your brain to fix this bug, you don't have to think about the bug. What you do is you look at a trace, and the trace says this happened, it was these parameters at this particular time, and this is what else was going on. And you go, oh, right, yeah, it's in that class. I've done a little thing. It makes it work. Awesome. Let's pass it back. I've not had to page the current feature out of my brain in order to make room for the current one. which means that I don't have that spin up time. Everybody knows when a bug lands on your desk, if you spend an hour doing it, you might as well get rid of the whole day's progress on that feature you were doing, because you've got to page out the current feature, do all of that work, then page in the other feature, which is probably going to take you another hour or two to get back up to what you were. So you end up writing more code. And I like writing code. I'm sure most people like writing code. At the moment, my IDE is PowerPoint, which I don't write much code in PowerPoint. But I'm imagining that most people whose IDE is not PowerPoint do like writing code. So making it more observable actually helps you write more code.
So I think it's pretty universally accepted that making production systems observable is a good thing. What about making early development environments or your local environment, your laptop observable? Is it a good thing?
Okay, so there's a couple of parts to observability-driven development or observability during development. So part of it is the observability-driven development is I can use my observability to help drive the behaviors of my system. So I can develop with observability in mind and develop observability into my tests. So I can use my unit tests or integration tests or whatever term you want to use for the tests that you run locally in your unit testing framework, like JUnit, NUnit, whatever XUnit variant you're using. You can use that to drive the behavior of your tests, because observability is an output. And if you care that that observability exists in production, you can actually write tests around it. And if you're writing tests around it, you can use those as part of you driving the development cycle. You can say, well, if I'm in production and I would like to know the amount of hits that hit our cache versus the amount of hits that didn't hit the cache. Well, that's an observability trait, because you're wanting to understand the inner system state of what things were hit. Well, what happens when somebody removes that from your code? Do you have a test for that? Well, actually, no, there's a requirement here. My non-functional requirement is I need to be able to know what those hits are. Well, actually, that's observability features driving my development. Now, the other side of it is observability during development, which is the idea of using telemetry data to understand my system.
Yeah.
And that's really where power comes from a developer perspective. Everybody's seen the Monzo diagram of 1,500 microservices, and most ops people went in a room and cried when they saw that diagram. And all the developers went, I'm not developing anything ever then. Because that idea, in fairness, they were doing proper microservices where everything had a bounding context. And what we end up with now is a kind of hybrid distributed monolith type scenario. And let's just say it right now, distributed monoliths are not a bad thing. Building a distributed monolith and calling it microservice is a bad thing, because it gives people the wrong idea. But distributed monoliths in themselves aren't a problem. They are a problem from a developer standpoint, because all of a sudden the footprint of what I need to run is larger. I can't run one unit test anymore because I'm reliant on these 12 other services to be up in order for me to debug. Now, if I can use observability in those scenarios to understand how my system is going right, I run all 10 microservices, and I can use those, I can funnel them into my observability solution, and I can use all the trace data that comes out of those to understand whether the feature that I'm developing is going down the right paths. When it breaks, did it have the right data in those scenarios? Was it service X and I'm developing service Y? Was it service X that brought back the wrong data? Well, ultimately, if I can do that locally, that's probably important to me in production. So not only am I helping my local development workflows, because until somebody develops a distributed debugger that will stop all of the services and allow me to step through every single service in my IDE, I'm going to have 10 debuggers running if I want to debug all of these areas. Until somebody develops that, I need something like tracing and distributed tracing to be able to see that. Well, if I can do that locally, I can do that in production. And then if I can do that in production, it means I'm going to be fixing less bugs or spending less time fixing bugs, which means I can write more code, which means I can write more observability, which means I'm now fixing less things because I'm now understanding my system and I'm running it and I'm understanding it from the perspective of production.
Yeah. I think you were generous by saying that distributed monoliths aren't a problem in themselves. So my experience has been that it's such a bigger problem, because if you've got all these distributed pieces, but they're all tightly coupled, and you need lots of teams to manage them all, and all those teams depend on each other, then it's just from an organizational design perspective, very, very difficult, because each team can't work independently. So you're overwhelmed with bureaucracy and coordination to do anything. That's been my experience. But that's well beyond sort of observability.
Oh, there's an entire 4-hour podcast we can do on that if you'd like. But what I'm meaning is that in certain scales, yeah, they're fine. If you've got a 5-service solution, throwing an event backbone in there and writing event contracts and trying to run things with a full purist EDA methodology is probably not the right answer if you don't care about resiliency and that kind of stuff. Like the whole point of somebody, we ran something recently. We were talking. We have a little card game. If you've played Exploding Kittens, and we have a tournament that's been going for years now. And one of the guys who runs it is a Kubernetes guy. And there was a joke running that we had a little website. It was a static website that was running on a 9-node Kubernetes cluster that was resilient across 3 different availability zones to run a static website. Wrong solution for that problem. So yes, ultimately I would prefer a full microservice driven solution, but that doesn't mean it's the only answer. Yeah. And if it's not the only answer, how do people who have this problem in this distributed monolith world, which in their scenario is probably the right answer, how do they have better tooling? How do they have better things? Because everybody needs nice things.
Putting you on the spot here, have you got any stories of either from your own experience or your customers of observability during development finding something really critical or interesting?
We actually have one recently from Honeycomb, because we honeycomb our honeycomb, as the saying goes. So you may have seen our new feature called our query assistant, which is a generative AI large language model thing that was built by the teams. That was the ability to query people's data with a bit of natural language. So beyond just let's throw things at OpenAI, it's actually a large language model built on our data, on the way, well, not specifically our data, but the ways in which people query. So it understands how people observe systems, not just a generic solution. And one of the challenges they had was performance. And they were actually using Honeycomb to honeycomb their honeycomb. And during that cycle, we wrote a blog post exactly on this. And what they could see was a large gap in a distributed trace between somebody putting the question in and the actual query coming back. And there was just this big, large gap in the middle of a distributed trace. And they didn't know why, but because they saw a large gap in their local environment with this trace, they started to add a bit more observability in there to understand what it was. And they actually worked out I think it was a regex parsing thing and tokenizing thing, which they managed to optimize and then bring things a lot faster.
Brilliant.
And there's a whole blog post on exactly how they did it. It was fascinating to see that just using distributed tracing locally was able to spot that. Even though it was a performance issue, which you normally get at scale, just being able to see this big gap in the middle is like, but why?
I would imagine Honeycomb on the spectrum of like very advanced, mature observability to, literally nothing. I'd say Honeycomb's way down this end of the spectrum. How sort of prevalent or popular is observability during development? Do you think across the world? Is it happening?
I think it is. I think there's people using it in different ways. So we talk about logging in the vein of legacy observability. It's there. I wouldn't use it now because distributed tracing is far better and provides far better things. But ultimately, that's what a lot of people have been doing for years. Console.log, I'm here. Console.log, I'm also here. Everybody's seen them. If you go on a lot of websites today, you'll be able to see in your console a lot of I'm here, because people leave them in and deploy them to production. Logging really is legacy observability. And people have been using that during their development cycles for years. They'll run up their application and they'll look at the output of a log. It's not the end of the world in terms of observability locally. When you start to run, hundreds of thousands of requests through that, it becomes a correlation nightmare. And then you try and add on distributed systems on top of that. And the fact that time doesn't exist in one machine, it exists on lots of machines, everything becomes a lot harder with logs. But if you take that back and say, well, actually, yes, everybody's been doing observability during development for years because they've been using console.log or console.writeline. What we're seeing now is people then going, well, I can't do that. I've got 10 containers that I've done a Docker Compose up on, and I can't look at each of those containers. And then going, great, well, now I will just run Jaeger locally, and I'll send the distributed traces there. I think what we're starting to see, though, is people doing it in more complex scenarios and starting to rely more on it as a primary mechanism for doing things locally.
Do you have any advice or tips for sort of encouraging development teams to do observability during development?
I think that the main thing is understanding how easy it is to do distributed tracing, because I still see teams today that go, ooh, distributed tracing, it's pretty hard though. I don't really want to invest in that. But with OpenTelemetry and the push that OpenTelemetry is doing around easy mode and easy button type stuff, where like .NET, which is my primary language, you can get it up and running in 10 lines of code. You can have distributed tracing on 10 lines of code per service, and then you've got it. So getting people to start to move to that is probably the starting point. And then once you start moving to that, think about what you might want to run locally to visualize that sort of data. There's quite a few tools out there now. There's a big industry now around local observability tooling, like Jaeger. The OTel desktop viewer is another one. And I'm sure we can put some links out with the podcast for you for your viewers to, or listeners, to have a look at. But I think that idea of getting distributed tracing in is probably the hard part. The other place to get started is really to look at the difference between manual instrumentation and automatic instrumentation. Okay. And I'm thinking about the SREs that don't change code. And there's probably another 4-hour podcast in SREs that don't change code. But the people who don't or can't change code, where they add an auto instrumentation agent on, they are going to struggle with this. When we talk about observability during development, we're talking really about manual instrumentation. So if all you're doing is automatic instrumentation, the first thing is moving to manual. That doesn't mean losing anything at all. It just means that you're being more intentional about what it is that you understand. So those scenarios where you've got an SRE team or a Kubernetes deployed environment, God forbid, and there's another 4-hour podcast in Kubernetes as well. But you've got these people and they deploy the operators that automatically instruments with distributed tracing all of the services. And you don't do anything in your code. First thing to do is to tell them that you want to do that manually because you want to add extra bits in there. And as soon as you start doing that, that's when you can really get started with being more intentional about observability. Because until you start being intentional about it, you can't really use it in development as well.
It makes sense. I'm highly skeptical of auto instrumentation as it is, but I'm guessing there will still be some value as long as you can see my service was called at this time and here's the status of what happened, and then here's the thing, what time I called the things downstream, and here's how long it all took and stuff. I guess there's some value in that, but probably less so from a development perspective where you're trying to get a little bit more fine-grained in that or focused on particular areas of importance. Is that
yeah. So when we talk about distributed tracing, what we're really talking about is how do requests transition process boundaries. Okay. And when we're debugging software systems, that's kind of like 1%. So distributed tracing, the automatic out-of-the-box stuff is really going to give you how we transition process boundaries. So I called a database. I called another service. I hit a gRPC call. I sent a message to a message bus. That's really the level to which you get that information. And when we start talking about debugging complex systems, we're not saying, did I start processing a message? Did I get a web request? Did it call another service? We're really talking about the guts of the application. We're talking about which one of my strategy pattern classes did you hit? We're talking about the algorithm that we ran. What were the inputs to that? Did I pass in the right inputs? When they came out, what were the outputs from that algorithm? And that is where you go, in production, I'm really going to need this information. So locally, I should probably want this information. So automatic instrumentation doesn't know where your crown jewels are. They don't know where that algorithm is. They don't know how the algorithm works. They don't know how to instrument that algorithm. You're the ones as developers and engineers. If you're SREs, you know where that particular gnarly bit of code is. Well, really, you want to add that in there. And then when you debug it, you want to be able to say, did I get the right output from the algorithm? Oh, is that algorithm that's a problem?
I think I know the answer to this already, but what are your thoughts on OpenTelemetry?
There's levels to OpenTelemetry. There are things I like. There are things I'm not so keen on. The main thing I love about OpenTelemetry is the protocol. And that is because it's been game-changing in terms of adoption. Because the protocol makes it agnostic of vendors, which means that you can now decouple all of your decisions about observability to later. And it's going to be easy to switch later. So what you use for local development, what you use for your development and staging during R&D might not be the same as what you use in production. And you don't need to care. You know, in the .NET world, way back, the first 6 months of any project was deciding which logging framework you were going to use. Is it Log4net or Nlog or Serilog? What are we going to use? And there'd be 6 months of arguments about it. And then .NET brought in something called iLogger, which was a generic interface that was part of the framework. And then everything would go through iLogger, and then off the back, you'd be able to choose which logging vendor or backend you were going to send your logs to. And I see OpenTelemetry in exactly the same way. Because now if everything abides by the protocol, you don't need to decide which vendor you want to use. So we can now, in our local dev world, we can say, I'm going to send it to the Hotel desktop viewer, or I'm going to send it to Jaeger. And then in production, you can go, I'm going to send it to Honeycomb or one of those. I believe there's other vendors that do some SaaS solutions. I don't know. But you can decide that later. You know, you can get started with your development. You can start using the tools that work for you locally, and then you can decide later. That protocol is really at the heart of why OpenTelemetry adoption is desired by organizations now.
My company is quite excited by the OTel semantic conventions, because our product doesn't ingest data, but it does store metadata about things, and that would like make it easier to connect dots. You slide there. What?
So semantic conventions is one of the things I'm, let's just say, not so keen on.
Really? Okay, that was interesting.
There's only two hard problems in computing, yeah, which is caching, validation, naming things, and off-by-one errors. We're hitting number 2. You know, the semantic conventions are amazing. The problem is that getting anybody to agree on what the right naming is hard. So for the viewers out there that don't understand what the semantic conventions are, so the semantic conventions were designed by OpenTelemetry as a way of naming attributes on spans, on tracing data, on metric data, naming labels, attributes, and that kind of stuff with consistent names. So backend vendors can assume that a http.requests as a metric means the number of requests that has been taken. They can assume what kind of metric it is. They can assume what granularities it might have. All of this stuff is some things that vendors can assume. And that's great. But around 6 months ago, the Elasticsearch community, which have been doing log aggregation for many millennia, I think. I believe there's some hieroglyphics that were aggregated way back. So they have what's called the Elastic Common Schema. And that's been around for way longer than OTel Semantic Conventions has, and is more widely adopted because it's been around for longer. That was merged in to the OTel Semantic Conventions, which changed a lot of the semantic conventions. Now, the semantic conventions have been experimental since the start, or the majority of the semantic conventions have been experimental. However, we now have millions and millions of applications using OpenTelemetry. They are using these semantic conventions, but they've never been made stable. So when Elasticsearch said, here you go, here's the common schema, you can go and use it, we're donating it to OpenTelemetry. And they said, yes, great, we'll change all of the attribute names across the entire of the ecosystem. And that has been a big bane of my life, because for the last couple of years, some of the people may have seen me on Twitter lamenting about the idea of why things aren't stable, like the ASP.NET Core instrumentation libraries, or the Flask libraries for Python, they're not classed as stable. And the reason they're not classed as stable is because the semantic conventions aren't stable. So because the names aren't stable, the libraries can't be stable. So yes, now we're in a mode where it's going to be October before they're actually made stable.
So it sounds like you agree they're a useful thing to have, but being conventions, they need to be stable, unfortunately, and they haven't been. So yeah.
Exactly. So I love the idea. In the same way as the protocol, standardizing things is great. Standardizing the names that people should use is great. One of the other problems is that OTel has been completely unopinionated on a lot of things. And because of that, it's meant that there's been various different standards. So I'm currently in the midst of writing a bit of a blog post for Honeycomb about the best practices for naming of attributes, or best conventions for attributes in general, like what should be an attribute, what shouldn't be an attribute, because OpenTelemetry don't want to do that for valid reasons, but they don't want to do that. But that means that you end up in naming debates in pubs at conferences all year round, which is exactly the right time to have a naming debate, is with a beer in hand.
So on my travels, there's been quite and things that have been posted online, there's been a fairly common topic of how much it's costing people to have these observability tools and to host all this data and to use it. It sounds like some organizations have got to a point where they're just spending a heck of a lot of money. And then you also have this idea of sort of monitor everything. You have any thoughts on this topic around should we monitor everything? Do we need to be thoughtful about it? Are there sort of patterns that we can apply to avoid paying $65 million a year for Datadog?
I mean, who would pay $65 million for a vendor solution? I mean, nobody would ever do that, would they? So yeah, we have a big drive at the moment around how do we educate people on how to do telemetry without it costing the earth. Mm-hmm. Because we consider ourselves to have a duty of care to make our customers not spend a small fortune with us, because it's just not sustainable. We did have a customer recently that came to us, and they were doing about 120 million spans per second. And their question was, can you handle the load? And we said, yes, because our sales guy is going to buy a small island with his commission. But the problem is that that's not useful. 120 million spans isn't useful because there's a lot of them that are going to be exactly the same. And what people generally miss is doing sampling properly. That's generally where people have a problem. They will either do sampling at the vendor side, which means that you've already paid a ton of money to egress that traffic over to your vendor. And then that you've paid money from the vendor to generally a smaller fee, just to ingest that data, and then they will discard a load of data and keep some samples. And what they then end up doing is they don't have control over what's sampled and what's not. So then they lose value in sampling and tracing. Because the interesting stuff I wanted wasn't there. And we can't store all of it. So we just had to get rid of tracing, and we'll just use metrics instead. And we'll do guessing, the whole idea of it's George has a problem again. With swords and metric, it went up a little bit. Well, go and investigate it. Oh, no, you don't have traces because we've had to get rid of them because it's too expensive. And that's what I see as people have a problem. They don't know how to sample properly.
And so where do you sample from if you don't do it from your vendor?
Your side. You do it inside of your network. You either do it and you do a combination of head-based sampling and tail-based sampling. That's 2 4-hour podcasts. So I think we're up to 5 more 4-hour podcasts. So head-based sampling is where you make a decision right at where the entry point to your system happens. So like the front-end API gateway. So you have very little information to go on. So you basically just know, is it a bot? If it's a bot, I'm going to do 1% or I'm going to do 0.1%. Is it the health check endpoint? Yeah, we're going to drop that down a little bit. Oh, look, it's the checkout. Right, okay, I don't want to sample that. And then tail-based sampling is something that happens after the request is finished. So you send all of your spans, all 120 million per second of them in that scenario, to some centralized services inside of your network. And then that particular system will make a decision once it's got all the spans for that request. And it will say, well, this is just the same as the last one. Well, I'm going to I only need like 1 in 1,000 of these. Mm-hmm. So I'm going to drop that. I'm going to drop 999 of them. I'm going to send one to my vendor and say there were 1,000 like it. Mm. And the vendors who can take that into account, those ones are able to show you a graph that looks exactly right. And they're able to show you samples of those that bits of data.
Yeah.
But what you're also able to do is say, oh, if it's any request that takes longer than 100 milliseconds, because generally everything's under 50, anything that takes over 100, don't discard it.
Mm-hmm.
Keep all of them. Anything that's less than this and less than that and less than the other, maybe it's whenever there was an error, even if it was just a retry, I want to be able to keep all of those. And that's how you can reduce those costs down, because yes, keeping absolutely every single bit of span data is irresponsible, in my opinion.
Can the OTel collector do this head and tail sampling, or do you need something else, some other sort of tool or product?
It can. It's getting better. I currently, especially if you're with Honeycomb, I wouldn't recommend it, because we have our own refinery thing, which does a lot more advanced sampling mechanisms. Okay. The idea is that ultimately that OTel collector is getting better at the tail sampling stuff and will get better and better over time. It does work at the moment. There is a tail sampling processor in there. The rules in there are good, but they could be a lot better.
Oh, thank you so much for coming on the show, Martin. I think I learned a ton, and it's been a really engaging, interesting conversation. So just thank you so much.
Thank you for having me. I mean, anybody who gives me a soapbox, I will come and stand on, and you'll have to kick me off. So you're going to have to stop recording and kick me out of the room in order for this to finish.
And to everyone else, thank you so much for listening in once again to Slight Reliability, and I'll see you all in 1 or 2 weeks' time. Bye.
Bye.